بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله وبركاته. Today we will begin a new unit which is the unit of probability, and the first chapter in this unit is counting. The first point we're going to talk about is the factorial. N is a natural number which is greater than or equal to 2. We call n factorial, and it's denoted by n with an exclamation mark, the natural number that is equal to the product of all natural numbers from 1 to n. In other words, if I have, for example, n factorial, this would be the product of all natural numbers from 1 to n. So if I want to talk about, let's say, 5 factorial, it will be 1 times 2 times 3 times 4 times 5. And by convention, 0 factorial is going to be equal to 1, and 1 factorial is 1. Let's see the first example. We need to simplify 6 factorial. This is in fact the product of all natural numbers from 1 to 6, which is going to be 720. This is also 1 times 2 times 3 times 4, which is 24. And if I want n plus 1 factorial, this would be 1 times 2 times 3 times 4 times blah 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 times n plus 1. So we stop at n plus 1. Well, let's see this quantity. 9 factorial is the product of all natural numbers from 1 to 9, and 6 factorial is the product of all natural numbers from 1 to 6. If we simplify from 1 to 6 in the denominator and 1 to 6 in the numerator, we get 9 times 8 times 7, which is 504. Let's see part E. We do it similar to part D. 8 factorial is the product of all natural numbers from 1 to 8, and 11 factorial is the product from 1 to 11, and we can simplify here 1 to 8, 1 to 8. We get 1 over 9 times 10 times 11, which is 990. Finally, part F. If we write n plus 2 factorial as a product and n factorial as a product, this is what we get. We simplify from 1 to n in the denominator and from 1 to n in the numerator. We get n plus 2 into n plus 1. Well, the factorial could be calculated using the calculator, and this is what we will see now. This is the calculator. And if I want to talk about, let's say, 6 factorial, I just press on 6 and then shift and this button to get 6 factorial, and this is equal to 720, as you see. Let's say I want to talk about 9 factorial over 6 factorial. This is the fraction. I press on 9 factorial over 6 factorial, and this is what we get. Now this calculator, the calculator that we have, the biggest number that could be calculated containing factorial is going to be 69. So 69 factorial will be this quantity, this number times 10 to the power 98, as if we have 98 zeros after the decimal point. And if we want to calculate, let's say, 70 factorial, this cannot be done using this kind of calculators, as you see here. Remember also that the calculator cannot solve factorials that contain variables like n. Now let's continue. Now let's see the first application. We need to write using the factorial notation this product. Try to do it alone. Try to write it using the factorial notation. Well, this is nothing but 5 factorial. Try to do this one. Well, this would be 9 factorial over 6 factorial, because after we simplify from 6 to 1 in the numerator and from 6 to 1 in the denominator, what remains is 9 times 8 times 7. Let's see this quantity. Try also to do it alone. Well, this would be 11 factorial over 13 factorial. Notice here that the bigger number is in the denominator because the total here is in the denominator. And finally, this quantity, this would be n plus 1 factorial, which is the biggest number, over n minus 2 factorial, the number which is smaller than that one by 1. Now let's see some tips about factorials. Remember, we cannot add in case we have factorials, we cannot subtract, we cannot multiply, and we cannot divide. In fact, the factorial is stronger than addition, subtraction, multiplication, and division in the priority laws. We don't have a 3.2 factorial because when we want to talk about factorial, n should be a natural number. So this does not exist. This also does not exist for the same reason, and 17 over 2 factorial also does not exist. Now let's see the arrangement and the combination. N and P are two natural numbers. P is smaller than or equal to n and it's strictly positive. Now the arrangement A and P is n factorial over n minus P factorial, and the combination C and P, which could also be denoted by open parenthesis np close parenthesis, this is n factorial over p factorial into n minus p factorial. Now these are two notations that will be used later in this unit. Let's see, we need to simplify this quantity, so we just apply the definition here. What is a 5, 2? It will be 5 factorial over 5 minus 2, which is 3 factorial, and this is 5 times 4, which is 20 after simplification, or we can use the calculator here. Now a 10, 1, also applying the main definition, we get 10 factorial over 10 minus 1 factorial, which is 10. A 10, 10 is 10 factorial over 0 factorial, and remember by convention 0 factorial is 1. Well, this quantity, this would be 1, and a n2, this would be n factorial over n minus 2 factorial, which is n into n minus 1, and finally this quantity, which is n factorial over n minus 1, which is 1, and this would be n factorial. Now let's go on talking about the combinations. We also apply this definition, which is 5 factorial over 3 factorial into the difference between 5 and 3 factorial, and this would be 10. C110 would be 10 factorial over 1 factorial into 9 factorial, which is 10, and C1010 would be 1 by simple calculation, and if we use this notation, this is what we get. Well, this is n2, this is n factorial over 2 factorial into n minus 2 factorial. If we simplify n factorial and n minus 2 factorial, we get n into n minus 1, and 2 factorial is 2. And finally, this quantity, this is n factorial over n minus 1 factorial into the difference between n and n minus 1, which is 1 factorial, and this is n. Well, the arrangement and the combination could be calculated using the calculator, and let's see how. Let's say I want to find A52. I press on 5 first, then shift multiplication, then 2 with an equal sign, and this is what we get, as you see, which is 20. Another example, if I want to calculate a combination, let's say we want to find the combination of 5, 3. So we press on 5, then shift division and 3, and this is equal to 10, as you see here. Well, pay attention, we must put here the bigger number than the smaller one. Let's say by default we began by the smaller one, 3, shift P, 5. This is what we will get. We will get a math error. Okay. Let's continue. Well, let's see this application. We need to simplify this expression. Try to do it alone. Well, by applying the definition, this is n factorial over 0 factorial, which is n factorial. Try to do this also. This is n factorial over n factorial, which is 1. Try to do the third one. Well, this is n factorial over n minus 1 factorial, which is n. Now this one, this is equal to 1. And this combination, this is also equal to 1. Now this combination, this is n factorial over n minus 1 factorial, which is n. Now verify that this combination is equal to that one where p is between 0 and n. Try to do it alone. If we begin by applying the definition of the combination here, we get n factorial over the difference between n and n minus p factorial times n minus p factorial, and this is nothing but np. Now verify that the sum of these two combinations is equal to that one. Try also to do it alone. Well, here I'm not going to put the verification. Try to do it alone at home and try to verify this statement. Now, in fact, all of these formulas could be memorized by heart, especially these two. Now, let's see the order. Well, let's say we want to make salad and we want to put lettuce, tomato, cucumber, salt, and olive oil all together. In this case, the order in which you put these ingredients is not important. So there is no difference in the order of these ingredients. If we put lettuce then tomato, it would be the same as putting tomato then lettuce. Whereas if we want to go, let's say, to the ATM machine and we want to take some money and the ATM asks about the PIN number, here the order of the digits would be very important, because if the PIN number is, let's say, 1, 2, 3, 4, and we press 1, 4, 3, 2 would not be the same. So sometimes, depending on the case, we're going to see that the order is very important, and sometimes we're going to see that it's not that important. Now, how do we differentiate between the two cases? This would be taken later on. But let's begin talking about something very important here. How many different three-letter words can you form from the three letters S, N, and O? So you have the three letters S, N, and O, and you want to form a three-letter word containing these three letters. Well, remember here that these words could have meaning and could be meaningless. It doesn't matter. Well, the first letter could be either S or N or O. Now, if the first letter is S, the second letter could be either N or O. And if the first letter is N, the second letter could be either S or O. And if the first letter is O, the second letter could be either S or N. Now let's go on to the third letter. If the first is S and the second is N, the third should be O. And if we have S and O, the third should be N. Similarly here, if the first is N and the second is S, the third would be O, and here the third would be S. And if the first letter is O and the second letter is S, the third letter would be N, and here we're going to have an S. Well, what are the words that we have? These are the words. We have SNO, SON, NSO, NOS, OSN, and ONS. You see that we have 6 letters. Now, how can we benefit from this number? 6 is nothing but 3 factorial. So the question asks about the number of different 3-letter words, and in fact here we have 6 different words. Now, how can we get this 6? This is 3 factorial, and the 3 is the number of letters here. Let's see another activity. Now we need the number of 4-letter words that can be formed from the letters S, N, O, and O. Try to notice here that we have one letter which is repeated, and we will see the difference between this activity and the previous one. So the first letter could be either S or N or O. Well, the second letter, if the first letter is S, could be either N or O. Now here N, we could have either S or O, and here, if the first letter is O, the second letter could be either S or O or N. While the third letter, this would be O. Here we're going to have N or O. Here we will have O. Here we will have S or O, and so on. And for the fourth letter, if the first is S, the second is N, the third is O, so the fourth would be O, and here it would be also O, and here we will have an N, O, O, S, and so on. Now we are not interested about the letters S, N, and O, we are interested about the number of words. So we will have this word, this is the second, the third, 6, 7, 8, 11, 12. We're going to have 12 words. Now, if we want to use the previous result, we should have 4 factorial because here we have 4 letters. But in fact, 4 factorial is 24. And we can notice from here that in case we have a repeated letter, we're going to divide by the number of repetition factorial. So here I have 4 letters. This is 4 factorial, and divided by, because we have 2 letters which are repeated, we divide by 2 factorial. Now let's see the example. How many different words can you form from all the given letters? Now if we have these 4 letters, how many words can we form using all the letters? And we want, remember, a 4-letter word. So here we're going to have 4 factorial, which is 24 different words. Now here, remember, it will be the number of letters over the number of repeated letters. So here we will have 5 factorial over 2 factorial, which is 60 different words. While this is parallelogram, it contains 13 letters, and we have letter A is repeated 3 times, so we divide it by 3 factorial. Letter R is repeated twice, so we divide it here by 2 factorial, and letter L is repeated 3 times, so we divide by 3 factorial, and this would be the number of different letters. You see how huge is this number? Now if we have such a word which is meaningless, in this case we have 9 letters. W is repeated 3 times, so we divide by 3 factorial. B is repeated 2 times, we divide by 2 factorial, and R is repeated 4 times, so we divide by 4 factorial. Now let's see this application. We need the different selections that could be formed. This is the first case. Try to do it alone. Well, here we have 3 distinct letters, so the number of selections would be 3 factorial. Try to do this one. Well, we have 6 letters. This is 6 factorial, but one of the letters is repeated, so we divide by 2 factorial, and this is what we get. Now this case, well, here we have 7 letters, 3 B's and 4 R's, so this is what we get. And the last case, here we have 9 digits. This is 9 factorial. 1 is repeated twice, 3 is repeated 3 times, and 4 is repeated twice, and this is what we get.